So we're going to talk about section 3.5, which is quadratic and power models. With this section, you may want to go ahead and just bring out your calculator. Now with this, we are going to be needing our calculator. There is a by hand method that you can use, which will be perfectly fine. However, I do recommend the calculator method just because it does work a little bit better. But I will start the first problem by doing it by hand, but as long as you have your calculator, it will actually help you out tremendously through majority of the problems.
So a parabola is asked to pass through the following points: 0, 5, 4, 13, and negative 2, 25. Now we're going to write an equation of a quadratic function whose graph is of this parabola. Now what that means is basically in general there are a couple of keywords as we are kind of working our way through this. And again, always look for those keywords. It said the word write an equation. Okay. Now previously when we talked about write an equation, we always wrote an equation that was linear, and it's followed by the word quadratic. Okay. And pretty much when we start talking in that sense there, we really only have two versions of these quadratic equations that we looked at. So we have y equals ax squared plus bx plus c. And our other one is y equals a parentheses x minus h quantity squared plus k. Now, nowhere in this problem did it actually talk about the fact that I have a vertex. And since it says nothing about a vertex, I want to be very cautious and not use this one here that is the one that has the vertex form. Okay, so since I don't know if it's got a vertex or not, and I can't assume any one of these points is a vertex unless they tell me, we don't ever want to look at this. Okay, so when in doubt, what we want to do is we actually only want to look at this one. Okay, so y equals ax squared plus bx plus c, and that was what we called the standard form of a quadratic. Now, when we look at that straight away, we're going to kind of use that to help us with the points that we have. And so because we have x equals 0 and our y value is 5, so we have 1 point on the graph there. What I want to do is I actually want to plug that point in and solve out for anything I can. Now, x equals 0 is always a great point if you have it. So if I plug in 0 everywhere I see x here, and I plug in 5 for my y value, because again, this is x and this is y, then that kind of tells me that c had to be 5. And we pretty much already know what c is. Now, the rest of the part is I need to figure out what a and b are. And that's where the other 2 points are. So we already know that we have y equals ax squared plus bx plus 5, because again, we know c equaled 5. So what I'm going to do is I'm going to take these other 2 points, so this one and this one, and I'm going to plug them in for x and y. So as I plug these in for x and y there, again, so the first point is 4, 13. You'll notice I say 13 equals a times 4 squared plus b times 4 plus 5. Again, we already know that c is 5. We've been able to solve that one out. But when I plug that in, I can't solve it out. All I can do is simplify. And since all I can do is simplify it there, we're kind of left with a really pretty equation that simplifies out to be 8 equals 16a plus 4b. Now, where did that 8 come from? Well, 4 squared is 16, so that's where that 16a came from, and then 4 times b is where the 4b came from. But again, you see this lonely 5 right here? I can take that and subtract it to the other side, and 13 minus 5 is where I get my 8. Okay, now I can do the same thing and plug again, but now with a secondary point. So let me plug in negative 2, 25. So again, plugging in x equals negative 2. Now this time I have to be super cautious and make sure there's parentheses around a negative number because it's negative 2 quantity squared. And so when I multiply that out, negative 2 quantity squared is 4, and then 4 times a is just going to give me that beautiful 4a there. And then we have that -2 times b, which is where that -2b came from. And again, that 5 over here, I'm going to go ahead and subtract it over here and get that 20. And now I have basically two equations that basically are a system. Okay, and so we are able to take the first one and get our first variable, and then I can take the second 2 points, plug them in separately into this equation, and get two separate equations where I know that now I have to solve the system. Now, this is where we learned about solving the systems of equations. You can use the elimination method or the substitution method. I'm going to go ahead and use the elimination method. So I'm going to take these beautiful equations and I'm going to take that bottom one here. And I notice B would be a great one to eliminate out. So I'm going to multiply everything on that bottom equation by 2. And so that's going to give me 40 equals 8a minus 4b. And now I can add the two equations together and the b's will cancel. And that's going to leave me with 48 equals 24a. Divide both sides by 24 and we get a equals 2. Well, now that I know what a is, and I already know what c is, let's plug a back into any of these equations up here to figure out what our b is. So if I plug in 2 into that equation there, so we get 8 equals 16a plus 4b. And if I plug in 2 for my a, that's going to give me 8 equals 32 plus 4b. Solve that out, which will result in b equals -6. So we've done the math. We've got a equals 2, b is -6, and c was 5. And now you can plug it back into your equation there. Now, did I have to go through all of these steps there and make that work? Absolutely not. So the first thing I notice is I've got 3 lovely ordered pairs. Okay, now this was to do it by hand. The fun bit about all of this is that you can solve all of these with the calculator. So I'm going to come over here and I'm going to go into Stat and Edit, and I'm going to go up here where we talked about making models with these before. So we've done linear regressions before, and so I'm going to kind of use that idea. And in list 1, I'm going to put all my x values. So you'll notice I put 0, 4, and -2. And then in my y values, I'm going to put their y counterparts in list 2. Now be very careful and make sure that as you're looking at these, you'll notice I made sure that the 0.05, it's all together in one row, 4, 13, and -2, 25 again. So Stat, Edit, plug in your points. Again, X should be in list 1, Y should be in list 2. And then we're going to hit Stat, arrow over to calculate, and then we're going to look for quadratic, which is actually number 5. And we're going to hit Enter. And again, it should already have list 1 and list 2 already stated in there, and we're going to say calculate. Okay, and notice, what did we get for A? We got 2. B, we got -6, and C, we got 5. So everything that we did by hand, the calculator will do the same thing. Now, I do want to make sure to know whether or not this is a beautiful exact or if it was an approximation. So what I'm going to do is I'm actually going to turn a mode on in my calculator. So I'm going to hit mode. I'm going to scroll down to statistics. Okay, and it says stat diagnostic, and it's currently off, so I want to turn it on. So I'm going to hit enter so the on is highlighted. So now when I go back and do that stat calculate number 5 there, calculate it, you'll notice I now have this extra thing in there, which is r², which is my correlation coefficient. And the correlation coefficient, if this number is exactly 1, it means that basically this is a perfect fit. This is an exact model. If this is anything but 1 or -1, it means that this model would be an approximate model, which means there was a little bit of probably a little bit of rounding involved. Okay, now for those of y'all that have the TI-83, so if you have an 84, this is really nice and easy. You just hit mode and then turn it on that way. If you have an 83, when you hit mode, it's not going to show that. It's a little bit harder to turn your stat diagnostic on. So the easiest way I have found is if you hit the second button, so you go to the home screen. So here's my home screen. This would be where I would add, subtract, multiply, and divide. Okay. Make sure that this is fully cleared out. and then you're going to hit second and then the 0 button. This will bring up the catalog. Now, you're going to scroll for a little bit here, and you're going to scroll until you see the D's, and you're going to look for diagnostic on. Hit enter when you find it. It should bring it to the home screen. This is why you have to have a clean home screen, and then just hit enter one more time and it will be good. And it'll say the word done. And now when you do run the quadratic regression, it will work. Okay. So stat, arrow over to calculate number 5. And then again, calculate it out. Now, for those of y'all that do have those TI-83s, please remind yourself that you're going to have to type in list 1, comma, list 2. So you have to make sure to put in that regression afterward, okay, of like what list is it actually using. Now, once you do that, you'll have that exact same answer that I have, okay? Now, remember that even though this is what A, B, and C are, my actual answer that I'm going to plug in is going to be 2x squared minus 6x plus 5. And again, this is literally me just plugging in what A, B, and C is into that model they gave me. So let's try this again, but this time let's do it in a more word problem format. So with the word problem that I have here, we have a ball that's thrown upward from the top of a 128-foot high building. Okay, the ball is 144 feet above the ground level after 1 second. Now it reaches the ground in 4 seconds. And then the height above ground is a quadratic function of time after the ball is thrown. Okay, so write the equation of this function. So again, as we take a peek here, the first thing I want to note is, again, those kind of key ideas here. I'm going to ask you to write an equation, but I'm telling you that it is quadratic. Okay, so again, automatically there, you know that the answer is going to be that y equals ax squared plus bx plus c. But in this case here, they didn't give me the ordered pairs in the traditional format. So what I do notice is that I have a couple of different numbers there. What numbers I actually have are very important to make note of. So the first one I want to make note of is the fact that I'm on a 120-foot high building. And then I know the ball is 144 feet above ground after 1 second. And then we know that it reaches ground level at 4 seconds. So I have basically 2 different types of things I'm talking about. I'm talking about how high something is and the time that it took. Okay. Now you'll notice on the very second sentence here, so the ground is 144 feet. The ball is 144 feet above ground level after 1 second. That right there is a beautiful ordered pair. And then it says, and it reaches ground level in 4 seconds. Okay. So they don't actually give me a number there, but they gave me the word ground level, and that's very important to make note of. Okay. So ground level would be how high? Well, the height would be 0, right? Because I'm not really anywhere. But then I have this 128-foot high, but I don't have a time that's attached to it. Well, that's where we start. So that's time 0. So if I look at all those together at time 0 here, at 1 second and 4 second, I have 3 ordered pairs. Okay. And so I want to put those all in the beautiful calculator there to kind of help me out. So let's put our calculator and let's bring it over again. Okay. And so we're going to go to stat. We're going to hit edit. And again, I've already got stuff in there, so you can just go right over it and type over it. Or if you want, remember, you can go up to the top of the list and always hit clear. Whatever you do, do not hit that button. That's a bad button. Clear and enter. And this will allow me to type in the new numbers without worrying what was originally in there. Okay. So I've got all my numbers in, so they're nice and in there. Okay. So there we have it. With that next part there, we now want to do our regression. Okay, so start by hitting stat again and arrow over to the calculate menu. So we're already here. So we're just going to hit stat, arrow over to calculate, find where it says quadratic, which would be number 5 there. Okay. Now, again, for those of y'all that are my TI-84s, this is what it's going to look like. You've got that quad reg, okay? and you're just going to hit calculate, and it's going to give you that beautiful answer there. Okay. Now, for those of y'all that are my TI-83s, again, with the TI-83, one of the things that we want to be a little cautious of is that it's not going to have that pop-up menu. So what it's going to do is only show quad reg. Okay, so when you get past that first step there, so once you get here, you hit number 5, this is all you're going to see. You don't see that menu here. You see this. And so for you guys, what you want to do is you're just going to hit second 1, comma, second 2. And then just hit enter. And then you'll get the same screen at the last as everybody else. Okay, so now that we have it all there, notice it does tell me what my beautiful A, B, and C are. Now again, do I have to have the R squared? It's not actually needed for the problem, but it is kind of helpful to go ahead and put it on and turn it on. That way you can kind of start to see it. It becomes really handy later on when we start comparing different models and knowing which one's the better fit. But the correlation coefficient, which is what R squared is, it doesn't make much of a difference for this section in general, but it does just kind of help me identify which ones of these are exact models and which ones aren't. Okay, and then all you have to do is now plug in what your A, B, and C are into your actual equation. And again, always look at the top up here. When you run the model, it tells you what the model is. So that's where that AX squared plus BX plus C. So do you have to have it fully memorized? No, the calculator will help you out there. But you need to actually plug in what A is. So notice how I replaced A with -16 like they told me. B is 32, just like they told me, and C being that 128. Okay. Now, so let's do this again, but let's do this with not just 3 order pairs. Let's do it with a little bit more. Okay, so let's start here. And one of the first things I want to do is I've got this beautiful table, and we're going to show the value of the projected dollar of the U.S. mobile internet advertising market for X years between 2006 and 2012. Now, as I work my way through this, always look through the problem, and somewhere in the problem, normally on either step A or at the very beginning in this first part up here, they're going to say, because this is a big key thing here, the fact that I have years, I always want to look for something. So it's going to tell me in part A that we want to create a scatter plot where X equals to the number of years after, and it's going to say some number here. Okay, look for that. Now it's not going to have this exact, it's going to type it all out, but always look for kind of that 0 year. In our case here, we're going to use 2000. Now, why do I want to make sense of what is the 0 year? Well, ladies and gentlemen, that's where when I start off here, I want to go in and say, okay, stat, edit, and I'm going to clear out what I have because I want to start super fresh. Okay, so list 1 and list 2 are completely clear. And instead of typing in 2006, I'm going to type in 6, because how many years have passed between 2000 and 2006? 6. Now, if you're unsure, go ahead and type in the year and subtract out whatever your 0 years, and that's going to be a great way to get that in there if you're not 100% sure. So we know that this is 6, 7, 8, 9. And then again, over here, as I go into these years here, I have my 10, 11, and 12. And then over on my list 2 part, I'm going to arrow over and I'm going to type in this part right here. So we've got a 0.045. We've got a 0.114, a 0.273, and so on. Okay, so as you type these in, make sure, especially with these ones here, you've got quite a few, and you want to make sure to type them in with accuracy. Okay, so double check as you go back up here. Sometimes you need to go back, make sure that list 1 is not too large. And it's very important to make sure that if you see that whole X is the number of years after something, that you go ahead and do that. Now, the other thing that you can do is go ahead and do a scatter plot. So I'm going to hit second Y equals, and I'm going to plot my scatter plot. So I'm going to turn it on, make sure plot 1 is on. I'm going to make sure that scatter plot's selected and list 1 and list 2. Again, doesn't matter which marker, doesn't. It doesn't matter what color you use either. So if you are just one of those people that really likes to have the colors on it, go for it. Now remember that when we graph, we always want to double check in Y equals. If there is stuff in here, go ahead and clear it out. We've already turned plot 1 on, so you can see it there, it's on. And then I want to hit zoom 9. We always want to hit zoom 9 when we do our beautiful scatter plots there, because again, that is going to be the kind of key indicator that we've got stuff in the list. Now, as I take a look at that, one of the things I begin to notice is this isn't absolutely perfect. It's kind of got a little bit of bumps along the way. So we can see that it does look like it is kind of partially quadratic in the sense of it's kind of a part of a parabola. So this would be a great way to figure out, okay, so we see it. Quadratic would be actually a reasonable thing for this answer here. Okay, so let's actually find what we call the quadratic function that is the best fit. Now, again, I'm going to point out those keywords there. It is best fit. Okay, sometimes we also use the word model, or we can use the word regression here. So please be cautious of that. If I use any of these 3 words, best fit, model, or regression, this means that you cannot really do it by hand. The calculator must be used here. Okay, so we've already entered in our 6 through 12 in that list 1 on the graphing calculator. We've already done our outputs in the second list. And so now we're going to use our regression part of it. Now, with our regression part here, you're going to notice, and I'm going to kind of actually pull the calculator up so you guys can see again. So we're going to go to stat, arrow over to calculate, and we're going to hit number 5. Again, run your calculation, okay? And as you ran that calculation, again, for those of y'all with my 83s, make sure you say list 1 and list 2. You'll get this beautiful thing here. Now notice that we turned on r squared, and now r squared is 0.997. What that tells me is that it's not an exact fit, meaning there was a little bit of wiggle room there, okay? And what that does is, again, if this was a perfect 1 or -1, then it's a perfect fit. This is why we have to use the word regression, model, or best fit. It's not a perfect fit. So these are not ones that can be done by hand. They will need a little bit of calculator help. Okay. Now go ahead and round. You'll notice you've got a lot of decimals here, and you're going to need to round based upon what they tell you. So look at every single problem that you're doing, and make sure that when you're looking at the problem, when you're doing the homework, that it tells you how far you need to round to. Now for this one here, we're going to round the coefficients to 3 decimal places. Okay, now I'm going to use a word here that is probably not one that you guys are used to using, but it does start to make its appearance as we look here. So even though I said the word 3 decimal places here, this one here, you'll notice I have more than 3 decimal places. So I'm going to add in a keyword here, 3 significant. Okay, 3 significant. Okay. Now, as we look at 3 significant digits, what that means is that you are looking at something that should have 3 numbers other than 0. Okay, so when we start with 3 significant decimal places, that does not necessarily mean just 1, 2, 3. It means we need to look at the numbers. I'll pull the calculator back up so we can see it one more time here. As we look here, we start counting at the first number that is not 0. So start at the far left and go da, 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 until you see one that is not 0. And then that's where we count 1, 2, 3. Okay, so this is why I rounded this one to a 0.0149. Now here again, first number that's not a 0, there's my 1, and then start counting 1, 2, 3. Now I know the second one there is a 0. Don't let that one bother you. We always start at the first one that's not a 0. So again, go until you see the first number that's not a 0 from the left to the right, and then you start counting. Okay, so watch for this key word there. If I use the word significant, that's when we start counting, and it doesn't necessarily mean you have 4 decimals. It means that there's 4 significant digits. So when it says round to 3 significant decimal places or 3 significant digits, they can kind of go either or. You want to kind of watch out for that there. Okay, now let's take a nice lovely peek at that in my y equals. So what I'm going to do is I'm actually going to graph that in my y equals. So I'm going to pull my calculator back up and drag it to the side here real quick. So I'm going to go into y equals. We've already plotted it, so we know the graph looks like this. So I want to see like how well does it actually look. So I'm going to type in that 0.0149x squared minus 1.0, sorry, hang on, made a mistake, 0.105x plus 0.137. Okay, double check, make sure that you did type it in correct, and then go ahead and hit graph, and you'll see there that you've got that model to kind of help you look there. And you'll notice on that model, it does look pretty close. Again, is it absolutely perfect? Does it go through the middle of every single one of those points? Sadly, no. Okay, so it looks pretty close, but it's not perfect. Okay, and we can kind of see, and I made it a little bit bigger here, that it's a little bit high here. The point is, and the point here is a little lower. This one, it kind of goes through really well here and kind of here too. But again, it kind of clips this one, clips that one, and a little bit better on this one. So this is why we say that it's a model, it's an approximation itself. Okay. Now, if I ask you to take that model and use it to solve for something, I can do that as well. So if I ask you to take that model and use it to find, we can do that by basically taking just the model. Now, if I'm looking at just the model, remind yourself that the dots are going to go away. So with that, we would want to kind of go back up here, go to y equals, and you can either clear this out or you have the option just to turn it off if you need to turn it back on in a little bit of a moment. So I want to take those dots and just turn them off. So you can just kind of go up to plot one and highlight it and hit enter. And so when I graph, you'll notice my dots disappeared, but everything is there nice and perfect. So it's actually already kind of in the format that I want to see. I wouldn't have to make as much of adjustment. Okay. And so I'm interested in when it actually equals y equals 3. So I would go into y equals, I've already got my model in there, so it's there. And I'm just going to put 3 from the y value, and I can graph it. Okay. Now I noticed right away, I put it in, but I didn't see anything. Okay. Now why is that? Well, let's double check. I know I put it in. So why do I see it here when I made my graph here, but I don't see it here? Well, again, make sure that these have the little black marks on them, so they do, but I'm going to hit window. And I notice when I hit window right away, straight here, do you see how this says 1.18? And I know that my line is at y equals 3. So I need to actually make this window up a bit higher. And this is where sometimes the calculator has stuff, but it may not have everything. So I'm just going to change that to 4. So now I can see above it, but now I can't see where they cross. So remind yourself again, I'm going to need to make some adjustments. So I'm making the adjustment over here, which is my X max. So make it a little bit bigger. And I'm telling you, your guess should be about 20 right now currently. Okay, so we've got that there. And then once you have that, you can now see where they cross. This is where when you are looking at those intersections with a model, you are going to have to make a lot more of an adjustment to that window as you see fit. And then we can run that second trace number 5 for our beautiful intersection there. Okay, I do recommend if you can get it as close to as possible, that helps. Does it have to be perfectly on it? Absolutely not. So hit enter, enter, and then go ahead, and I do strongly encourage to kind of get it close to the guess as you can. Hit enter, and there's our intersection. Now remember that X is the number of years after the year 2000, so you will need to kind of add that in. And again, this is a partial year, so we normally with years, even if it's like a 0.1 or a 0.2, we normally almost always round up to that next year. So you'll notice that's why I said it was the year 2018. Again, I don't even care if this was like a 17.1, I would always round up to that next year as we see fit there. Okay. So guys, that is pretty much mostly what you need for 3.4. I do recommend the calculator route to kind of work your way through it. Are there other things that you can do? For sure, but again, I strongly encourage use the calculator. Be aware that in most book settings or most view and examples or tutoring settings, that are done by computer generated items, they're going to show the by hand method. They're not necessarily always going to show the calculator method. So I recommend try to do the calculator method. It's going to be a little bit easier, and it's also something you've done before with that linear modeling. So this is kind of like a carry on, and it's going to follow us throughout the rest of this course.